My first CNC router build used dimensional lumber and skate bearings. It was not very good. I need a better quality CNC router for projects going forward, so I decided to design one from scratch and build it out of steel. In this video, I'm going through the design, the assembly, the testing, and the results of building what I call the Ferris CNC, an all-steel homemade CNC router. I'm Josh Whitman, CEO of Whitman Technological. I spent about 2 years building the first version of this table. It was made out of dimensional lumber and skate bearings. I had a few design considerations for this project. I wanted the frame to be extremely rigid, so I wanted to make it out of steel tubing. And my dad works mostly with fiberglass, but he does have a plasma cutting table and a 100-ton press at his shop. And he's told me several times that if I needed anything plasma cut or bent, he'd be happy to do that for me. When I put all this stuff together for welding and for finished assembly, I was going to be using mostly hand tools. I needed to have the structure be forgiving enough that I could make kind of inaccuracies and it wouldn't make the router less accurate in total. So with all that in mind, I hopped into FreeCAD with a blank slate and started building up from there. Using FreeCAD's sheet metal workbench, I flattened all the bends and generated the DXF drawings to send to my dad for his plasma cutter. And I wrote up a set of instructions on how to orient and bend the different brackets that he would be cutting for me. I wasn't totally happy with the orange and blue color scheme that I had originally set it up with in FreeCAD. So having exported it to Blender and being able to render it with some degree of accuracy, I tried a couple different color arrangements. I thought the blue and black color scheme ended up looking really sharp and settled on having it mostly black with some blue highlights. I reached out to a local metal supplier, SMC Metal. I ordered all the parts I needed, and then when they were cut and ready, I went down and picked them up. My dad shipped up the plasma cut and bent parts for me. Now that I had everything I needed, it was time to weld and paint the frame. By now, it's been over 2 months since I started designing this router. It was still fall when I began, but it's definitely winter now. My wooden router is taking up a huge chunk of the basement still, so we're going to have to take that apart before we can put together the new router. I'm fairly sentimental about this kind of stuff, so I gave my old router one last project, a sort of passing of the torch. When that project was done, I took the router apart.
To the table.
Stay strong. Stay strong.
To the table. To the table. Ain't easy, I can tell.
I can tell.
Gotta stay strong, stay strong.
To the table.
Stay strong. Stay strong.
Ain't easy, I can tell.
I can tell.
Gotta stay strong, stay strong.
We can use this wood from the old router to make a stand for the new router. I'm something of a master carpenter, so it should be pretty easy. When I received my ball screws, one of them was really badly bent in shipping, and I did not know how to deal with this. I looked up some videos on how to straighten them, and I just don't have the equipment. Like I said before, I'm just working with hand tools, and these ball screws are fairly thick steel rods. They're not easily bent. So I wandered around my house trying to find the heaviest thing that I owned that I could use to try to straighten this, and ultimately the only thing that was heavy enough was my house itself. So I ended up jacking the ball screw up using my 2.5-ton car jack against the an I-beam in the basement that's holding up the first floor of the house. And it was really sketchy. I was afraid it was gonna suddenly shoot out and unload all of that built up pressure, and I was going to get struck with flying wooden blocks. By some miracle, it came out pretty straight enough that it works in the machine just fine. And now we're actually ready to assemble the router frame.
I need to know everything, who and the what and the where, I need everything. Trust me, I hear what you're saying, but act like it's new what you're telling me. I'm curious, George, I hop in the Porsche, it's 5 and a horse, I'm ready for war, I'm coming for throats, to turn to a ghost, I need to know everything. Now you be surprised at the info you get is by letting them talk, so I'm letting them talk. Gotta keep quiet, maneuver in silence, then let them in, chalk up their body. Another one body, that's just how it go. I got some secrets, I'm shaking the game so they stay on their toes. Stay in your lane, how to stay on the go. I can play with the pros and act like a rookie, so they overlook me. Then I double up again, none of their nose. None of them cold, they just got lucky but never adapted. So I'm turning to one if it's coming to blows. My enemies cutting it close. I let them think that they got me, but what do you know? I had them beat before we ever spoke. I'm ready for smoke. I need to know everything, who and the what and the where. I need everything. Trust me, I hear what you're saying, but act like it's new what you're telling me. I'm curious, George, I hop in the Porsche, 5 and a horse, I'm ready for war, I'm coming for throats, to turn to a ghost, I need to know everything. Now they ain't go harder than me, they need a blade and a sheath, a shank and a piece, a crate full of heat, an army, a fleet, a tank and a jeep, a navy at sea, with ace a marine, an ace up their sleeve, a team of marines, a freak on a leash, a beast with an appetite, razor for teeth, and still they would lay at my feet. Boy, you got the wrong one. I gotta look over all of my publishing statements for Q1 as soon as the song's done. I gotta call up my mama and tell her I made it as soon as my log's done. I gotta read all my trade publications and sip my tea till it is all done. I think it's all fun. I need to know everything, who and the what and the where. I need everything. Trust me, I hear what you're saying, but act like it's new what you're telling me. I'm curious, George, I hop in the Porsche, 5 and a horse, I'm ready for war, I'm coming for throats, to turn to a ghost, I need to know everything. I need to know everything, who and the what and the where. I need everything. Trust me, I hear what you're saying.
We're starting to see the light at the end of the tunnel, which is pretty exciting. We still got a ways to go, but oh boy, it's pretty cool. This frame is really awesome, but until we breathe the breath of life into it with lightning, it's not going to do anything useful. To control the motors, we're going to use an Arduino Mega 2560. Using a flavor of GRBL, we're going to have the ability to expand to 6-axis motion control. The extra pins on the Mega 2560 will also allow us to add whatever additional functionality we might need, because this isn't just going to be a router. This is going to be used as a multifunction positioning device. So just for funsies, we're going to add the ability to toggle laser guides on and off to the firmware to make sure that we have our fingers into the ones and zeros. Now the software that we wrote in previous videos for drilling out PCB holes and for sending G-code for the AutoPay reminder box, that software is expanding to become the primary controller software for connecting, jogging, setting the axes, streaming the G-code. And then we need to wire up the limit switches and the stepper motors, and we should have a fully operational router. Time to kick it into high gear and get this project all the way done. Okay, we have a fully functional router. There's definitely still some bugs in there in our software that streams to GRBL, and maybe a little bit in how we've set up GRBL with its acceleration control and stuff. But it's working. We can use it. My computer was set up across the room, and I was jogging it from like 6 or 7 feet away and trying to get the bit down to level where it was supposed to be. And it was really difficult. So I had an old chair, and I took that chair, I took the feet off of it, and in about a half an hour I was able to build this really nice computer stand for the keyboard, monitor, and mouse. And then I put the computer on the shelf underneath the table, and now I can put myself right where the action is when I'm doing the jogging and streaming the G-code. So let's chew into some stuff and see how it tastes. So the router can cut through wood, no problem. It had no problem cutting through the acrylic, even where we didn't want it to. And once I figured out where that bug was that was causing it to miss lines of G-code and ruin the project, I put the acrylic under the microscope to see how good the engraving was. And it turns out the engraving was actually super precise. The cuts looked really great, so I figured it was worth a shot to make a circuit board with the router. So I wrote a whole bunch of software that would do probing across the surface of the PCB and figure out the exact height at each point. And then I messed around with some averaging that didn't work, and ultimately went to Wikipedia for a bilinear interpolation algorithm. Once I had implemented that, the results I was getting from my test came out really nicely, and I felt confident that this code would do a good job with the actual circuit board. The result was so far beyond my expectations. This was absolutely perfect. The end result is, with slightly thicker traces, would have been a completely functional circuit board. So a desktop router cutting wood and acrylic and making PCBs, that's fantastic, but no router can claim to be really good unless it can work with aluminum. Now, I've never actually done aluminum before, never even attempted it, so I was a little out of my depth at first. I tried milling and I broke a bit immediately, so then I tried again a little slower and broke another bit, and then I tried slowing it down even more and shortening the cut depth, and I broke a third bit. I only had 2 bits left at this point, so I was starting to get kind of nervous that I wouldn't be able to do aluminum in this video for you guys. It was time to get serious. First, I raised up the aluminum so that the router wouldn't have this long torque arm where it was extending all the way down to that low bed. That torque arm is fine for working with stuff like machinable foam and machining wax, but aluminum requires a lot greater forces. Second, I checked all of the roller bearings along the gantry to see if any were loose. I found 2 bearings that could be tighter, so I used a clamp to add pressure while I tightened up those 2 bearings and made it a little bit more rigid. I shortened the cutting depth to 1/3 of a millimeter. Things were going pretty well, but as it got deeper and deeper into the cut, it started to have problems, and finally I wasn't able to stop it in time and my second to last bit snapped. I almost didn't try one last time because I didn't want to break my final bit. I had bought an air nozzle for the previous router, so I installed that on this router so that I could blow all the aluminum chips out of the way. I hooked up my air compressor outside and ran the hose through the window into the basement. With great trepidation, I started a new cut. Unbelievably, this is what it took to get a successful cut in aluminum. And the end result is a small aluminum probe I can use for setting the Z height on non-conductive workpieces. With the right bits, I expect it to be way easier to work with aluminum. If you're interested in building one of these yourself, there's a link to the website down below in the description. Now that the CNC router is finished, I can go back to plinking around with the robot project. I hope you enjoyed the video. Thank you for watching. And with any luck, I'll see you again in the future. I'm Josh Whitman with Whitman Technological. I love science, and I hope you do too.